Speaking of intent to investigate and the whole concept of digging into things, one of the other pieces of the Nexus that I think is very attractive to organizations is the security facet of it. That you're able to bring security closer in to the port level experience.
Or at least just attach it to the thing that should be secured.
Right, and Network Insight for Nexus helps address that as well.
Okay, and that really bore out in the user research. So one of the big findings we had was Nexus administrators were pushing security closer and closer to the endpoint, closer to servers. Okay, sure. So this materializes as more port access lists, PACLs, or VLAN access lists, VACLs. So we just recently worked on access lists with ASA, right? We did a ton of work with that with the new rule browser and optimization, stuff like that. So we basically took that functionality, extended it to the Nexus, and added on top of it. So two key adds is we do MAC address lists now. We also do non-contiguous subnet masks to the extent that you use them. So if we look over on the left-hand side again with that sort of subview concept here, we've got an access list subview, so we'll drill into that. And the first thing I'd like to highlight about the access list view is we version control each access list. So again, like the list view, this is not rocket science, right? This is,
but you keep saying that.
Yeah, but this is how it should be, right? So if you think about a simple question like, how has my access from this VLAN into my organization changed over time?
Right.
Before, that would have been really hard to answer. What would you do? You'd like look through your change controls and parse out commands, or you'd go and look at the version control for the whole config, and this device has thousands of ports, so there's a lot of noise. By version controlling each access list, it becomes a very direct question. You just look at the access list you're interested in, and you can see all the history of what changed and when. Okay? So all of your access lists come in here. Again, no extra configuration. Now, there's something going on with this ACL 01 IPv6. We've got some warnings over here. So I'm going to drill into that, and we'll go into the rule browser view. Okay, so this is the deeper analysis on a single access list. Now you can see we have our filtering and our sorting options as you would expect, line numbers, how we process, hit count, maybe a way to zone into the rules that aren't being used anymore. We've got search, which is a great way to find object groups and all that sort of stuff. We've still got the object group enumeration, so you click on an object group, we tell you all the members, all of that sort of stuff that you saw with the ASA. Now, there is one thing I'd like to highlight because I think it bears using. This works for ASA as well, but it's super effective. So basically, we're looking at a simple access list here, right? And we've got some sort of problem already, not good. And if I hover over this, you see it's warning about a fully shadowed rule. So I'm going to click to get some more detail here.
And just to point out that language is consistent with the language that that was used in the Network Insight for ASA. We're not inventing new language, whether it's a duplicated or a shadowed or whatever terms we used still work here. So folks who are used to the ASA world and now are starting to manage Nexuses.
And it's also an industry standard term. So if you're talking about a firewall where you would have a lot of policies, that is exactly the same thing that you're looking at here.
Yeah, so it's kind of like a 4x4 square where you have two terms, okay? The first term is fully shadowed versus, the first term is fully, the second one is partially, right? Okay. So if you think about access lists, the way a Nexus processes an access list, as you guys know, is it will take a packet and compare it to each line in your access list, one after another. Once it finds a match, it takes the action specified, permit or deny, right? Okay, so that's how an access list works. Now, a full redundancy means that you have some set of lines specifying this traffic, right? And then below it, you have a subset of that traffic that you're trying to take action upon, okay? And because the first rule already took action on that traffic, the second rule doesn't matter. It won't ever have any effect, okay? So this is a chance that maybe there's some sort of misconfiguration or optimization opportunity. So that's a full shadow. A partial shadow is when some of the traffic overlaps. Okay. Now the other piece that's important is whether this is overlapping or a shadow. Okay. Now the word overlap basically means that the rules are trying to do the same thing. Okay, so it will. Both rules are permitting. There's, you're just going to permit the traffic twice. It doesn't matter. Maybe you remove the second rule to make it a little bit easier to maintain and think through. But the really dangerous one is the shadow one, right? That's where the rules are trying to take a different action. Okay, so
based on some value.
Yes, so clearly like one's trying to permit, the other one's trying to deny, but the traffic isn't getting to the deny. So there's a contradiction in how the device is behaving versus what the administrator appeared to intend to configure it to do.
Right, okay. And whenever you have a serious fail with security, it's always that sort of occluded intent. Right, where you think you know how it's going to work. I mean, the code example is like unreachable code, right? In the previous example of it's basically blocked or it's denied by the first rule, and that second rule will never happen. But often in security, it's we had something right. Well, maybe we even got it right the first time, and then we've gone back over time and adjusted it or created some particular ACL for an edge case.
Yeah.
And that's where we end up in that situation where that intent is not clear.
Yeah, I mean, these access lists grow organically over time and they get really complicated. So we're seeing a really simple example with 2 lines here, but in production environments, you usually have dozens to hundreds of lines. And so this sort of optimization gets really complicated. There's a lot of math. Like if you think about allowing an object group with 20 subnets in it, to an object group with another 20 subnets in it. It's 20 times 20. For that single line, you have to calculate 20 times 20 and all the subnet mass. So I think math is something for computers to do and for people to understand, right? We understand what's going on, but computers, please do that math for me. So I've done this manually myself a number of times with access lists with 100 lines. And like you stare into the access list until your eyes bleed and you're crying.
You stare into the security
abyss. It just takes hours and hours, and there's a lot of risk involved because humans, we're not that great at math. So having it here in a way where it just pops up, I've expressed no special configuration to this, and I get the full details. This is really satisfying for me.